Alright, I think I got rid of my children for the time being, plus their hearts. And I popped this in too. I just multiplied that out while you were going. Or actually, you can see anything. Alright, so then I gotta do work. And I'm gonna call it. I'm starting at 5.00 meters. And I'm getting to 8 times 10 to the negative 10th meters. This is pretty close to starting at a force of 0 from our perspective. But we still have to work with it. It's going to be force times dx, which in our case is going to be minus, because it's going in the opposite direction of our motion. Is it alpha? Yeah, alpha over x squared dx, which is basically going to be negative alpha 1 over x squared dx. And that's going to be, well, again, we're going to move it up 1 power. So it's going to be, because this is x to the minus 2, moving it up 1 power is going to make it x to the minus 1 over minus 1 times negative alpha, evaluated from 5 to 8 times 10 to the negative 10. Alright. Well, let's see if we like that. That's okay. I mean, yeah, I guess it's alright. So we're going to have basically alpha over x evaluated from 5 to 8 times 10 to the negative 10th. So it's going to be alpha, which I think is 2.12 times 10 to the negative 26. So it's 2.12 times 10 to the negative 26. Evan? Okay, sorry. And then that's going to be 1 over 5 minus 1 over 8 times 10 to the negative 10. Well, that's just going to be some ginormous number. So it's going to be 0.2 minus 1/8, 0.125 times 10 to the 10th over meters. Which again is just going to be, 1.25 times 10 to the 9th over meters. This is 2.12 times 10 to the negative 26. I think they said it was Newton meters squared. And then it's going to be, let's see, it'll be 2 times 1/4 of that, which would be, 0.52 or something like that. So it would be 2.54 times 10 to the negative 17th Newton meters. Okay, that's the work done. I'm going to set that 2.54 times 10 to the negative 17th joules. I'm going to set that equal to what we had up here on top. This thing here. It's going to be, and it's going to be negative 2. Because this number's going to be so big that we're going to end up with negative, which is what we wanted anyway. And that's going to be equal to 8.3 times 10 to the negative 28. I should just cut it. 0.28 times 10 to the negative 28. V squared minus 7.52. 52 times 10 to the negative 15 joules. I'll bring this to the other side. Basically, it's going to be like having 752 minus 2.5. So it's going to be like 7.49 times 10 to the negative 15 joules. 8.28 times 10 to the negative 28 kilograms V squared. Well, we're going to have 7.49 e to the 15th negative divided by 8.28 e to the 28th negative equals that. That's my phone ringing, but you're more important than my phone by gum. So we'll take the inverse of this, and we get 3 point. Something about that bugs me. Yeah, okay. It doesn't bug me that much at all. It's like 3.00 times 10 to the 5th meters per second. Wait a minute. Yeah, that's a pretty tiny force, so it really didn't have pretty much the same as when it started. That's annoying, but it seems possible. Let me make sure the constant's right. It says how close does it get? So this time we're going to solve for from 5 to x. Oh, this is for part B. Okay. From 5 to x of minus, no, we said plus, didn't we? Alpha over x is going to equal enough energy just to stop it. It's going to equal this energy here. Negative 7.52 times 10 to the negative 15 joules. And because it's going to be 0 when it's stopped. And let's see what that is. So we're going to have 2.12 times 10 to the negative 26. 1 over 5th minus 1 over x equals negative 7.52 times 10 to the negative 15 joules. Well, we're going to divide those. 2.12 times 10 to the negative 26. 2.12 times 10 to the negative 26. We should get some ginormous number over here. 7.52 e to the 15th negative divided by 2.12 e to the 26 negative equals 3.54 negative times 10. This 10 to the negative or positive 11. And because this is Newton meters squared, we're going to end up with over meters. 1/5 minus 1 over x. Well, if I subtract 0.2 from that, I'm going to get the same thing. 3.54 times 10 to the 11th over meters equals negative 1 over x. Well, that means if I just flip this and this, I'll get the answer. So I'll take means that x is going to equal 1 over 3.54 times 10 to negative 11th meter, or sorry, yeah, the 1 meter on top, or positive. So we'll get, let's take 1 over it. That is, so x equals 2.81 times 10 to the negative 12 meters. That's really close. And it also explains why, you're really getting almost no effect by being at 10 to the negative 10th. I mean, you're not even close to having an effect. And C says, what is the speed if it comes back out 5 meters away? Well, this force is just going to be the same size. So it's kind of like, I think about like if you throw something up in the air, when it comes back down to the bottom, it's going to have the same amount of gravity, because gravitation was constant the entire time. You're going to end up with the same speed, just in the opposite direction. So the same thing is true here. You'll have 3.00 times 10 to the 5th meters per second, just in the opposite direction. Okay. That leaves you with 5, and I think only really one of those, 71, is real calculusy. So good luck. If you need anything, email or text. I will be around all day. Thanks.